Hey everybody. So in this video, we're talking about exponential growth and decay. So in this problem, we have a virus has infected 600 people in town and is spreading to 15% more people each day. Write an exponential function to model this situation, then find the number of people that would be infected in 23 days. Round to the nearest whole number. Okay, so this is your equation for exponential growth and decay. Anytime we're dealing with growth, we're going to say 1 plus the rate. And anytime we're referring to decay, we're going to say 1 minus the rate. So here, this is your initial amount. So this is the value that you start with. So the virus infected 600 people. So we start with 600. We are growing because it's spreading to 15% more people each day. So we're going to say 1 plus. The rate is always written as a decimal. So here, to go from 15% to a decimal, remember 15%. The decimal is here. You always move the decimal 2 places to the left. So we're going to say plus 0.15. And we're going to raise it to the time. So we want to know how much is left in 23 days. Now, the function, you would not plug in the 23 days. Here, I would just say 600 times 1.15 raised to the t. Or you could say raised to the x. Here, because they said f of t, you would want to use the t as your variable. For your function, what you're doing is you're leaving it like this so that I can plug in any number of days and get an output. So I want the population of the town in 23 days. So this is where I would plug in the 23. So I would say 600, 1.15 raised to the 23rd. And we're going to round to the nearest whole number, obviously, because we can't have a fraction of someone. So here, we're going to say 600, 1.15. We're going to raise this to the 23rd, and we're going to get 14,934. So here, this is about 14,934 people would be infected on the 23rd day. Okay? Let's take a look at another example. So here, the population of a small town was 9,700 in 2008. Since then, the population has decreased at a rate of 3.6% each year. All right, so decrease, we're going to say 1 minus. So here we have y equals the initial amount, so that's 9,700, 1 minus the rate as a decimal. So here, my decimal should move 2 places to the left. So this is going to be 0.036. And then here they ask, or they say, find the population of the town in 2025. So it started in 2008, but now we're referencing 2025. So I need to think, okay, how much time has passed from 2008 to 2025? Okay? So that's going to be 17 years. Now, remember, for the function here, f of t, you need a t somewhere in this exponential equation. That's going to be right here. The t stays if they only want a function. So here we have 9,700. And then 1 minus 0.036 is going to be 0.964. So this is our function right here. And now we want the population of the town, so we're going to plug in the amount of years that have passed, and that was the 17 years. So on a calculator, we'll say 9,700, we'll plug in or multiply it by 0.964, and then we'll raise it to the 17, and that gives us 5,200. All right? So here, I'll read this equation right here. We'll just copy it. So this was the equation that I put into my calculator to generate 5,200 people. And that's how many that would be left after 17 years. Okay? All right, here we'll take a look at one more. So 20 years ago, Mr. Davis purchased his home for $175,000. Since then, the value of the home has increased about 7% per year. Use an exponential function to find the amount of interest added to the value of the home. Okay, so in this problem, we don't want to find the value of the home in 20 years. We want to know how much interest was added to the value of the home. So we're still going to set this up the way we normally do. Y f of t. A is our initial amount, so that's our 175,000. It is being added, so we're going to say 1 plus the rate. So here we have 1 plus 0.07, and we would raise it to the t. Okay, this would be our function. This is the equation we're going to use to find the value of the home, but they want the interest added to the value of the home. So here's what we're going to do. We're going to say 175,000 times 1.07, and we're going to raise this to the 20. This is going to tell us the value of the home today. So right now the house is worth $949,800 and roughly 71 cents. All right. Now, this is not the amount of interest added. The house started at 175. This is what it's worth now. I need to subtract these two to figure out how much interest was added to the value of the home. So I'm going to say 949,800.71, and I'm going to subtract 175,000. So the amount of interest added to the value of the home is $774,800.71. So Mr. Davis has done very well and lives in an excellent neighborhood with a phenomenal school system if we are increasing 7% consistently every year. Wise investment, Mr. Davis. All right, that's going to be all for this video over exponential growth and decay. I hope that you found it helpful. If you have any questions, please leave them in the comments, and we'll see you all in the next video.